So what we are going to have a look at, we're going to start our work now. So what we're having a look at, guys, is we're looking at graphs. Our section that we're currently doing is functions and relationships. And we are today looking at drawing graphs. So this is one of my favorite sections in math. I just think once you start to fundamentally understand, excuse me, that a graph is showing you a relationship and you start to understand those relationships, it's just such a cool section. Oh, golly, one moment.
No problem. So guys, we have started, right? So meaning that we are all listening to Teacher Sam, and then we will ask our questions, okay? If you get any confused, make sure you pop up that question on the chat and I'll be able to assist you also. So let's do this.
Sorry, I just choked on some air. So guys, yes, functions, such a cool section. There's also so much overlap with other sections, like algebra comes into it, equations comes into it. There's so much. It's such a nice section. So I love functions. So what we have spoken about so far, and those of you that are new, I would really encourage you to go onto Watobe's website and watch both the videos from our pattern section and the first two videos from this course from last week, just to sort of help you get on track, but also understand hopefully the connections that I'm talking about. What we've spoken about a lot is the fact that we can express a relationship, or we can show a pattern between an X and a Y, an input and an output, or just two variables in many different ways. We have spoken about the fact that you can write an equation, you can draw a table, you can draw a flow diagram. And what we're going to chat about today is that another way to represent this relationship is through a graph. And so in order to draw that, often what is quite helpful is for us to go back to the table way of representing our relationship. Because remember, we spoke about the fact that if we want to draw a graph, we are needing to plot coordinates, and coordinates is always an XY pair. And if we look at our table, we've got our input, which is X, and our output which is Y. So if we can get an input and an output, we automatically have coordinates. And so a table is a very, very helpful way of us being able to draw graphs. But we'll chat about the coordinates more in a second. Let's first have a look at how we can find these outputs. So those of you that are new, this is a bit of a refresher for the others, but hopefully not too tricky. We have got this equation that we were given, y is equal to 3x minus 1. Okay, what we want to do is we have been given the fact that x is equal to minus 2. We have been given that the input is minus 2. We want to now go and substitute that into our equation. So if we go and substitute this, we have got y is equal to 3 times negative 2 minus 1. Remember, between your coefficient and your variable, you are multiplying. It is a product. Excuse me. So positive 3 times negative 2 is negative 6. Minus 1 gives us negative 7. And so what we've established is that our output here is negative 7. And we can do this for all of our inputs. If we move on to our next input, which is negative 1, we can do exactly the same thing. We can say y is equal to 3 times negative 1 minus 1. Positive 3 times negative 1 is negative 3 minus 1. And that gives me an output of negative 4. And so essentially what we need to remember is that anytime you've been given either your x or your y value, it really doesn't matter, you can use substitution to go and find the other missing value. So if I give you x, as I've done here, you can go and find y, exactly as we've done. I could give you y and you can go and find x. So it's very important that we're able to substitute and find corresponding outputs. So what I want you guys to do is I want you to find the outputs for the inputs of 0, 1, 2, and 3. And you are going to put those answers for me on the chat. So what I want you to do, and I need you to listen now carefully to this instruction, is I want you to do all of the working out first, get all 4 of your answers, and I only want to see answers on the chat of all 4. So A, B, C, D, all at once. Take your time, work through it, work through the substitution. Remember, if you have questions, ask them on the chat. But in a second or two, I want to see answers of A, B, C, D all in one go so we can check as we go along.
We have started. Let's go, guys. We can do this. That's nice, Shama. Shama can see the screen now. Thank you for letting me know. Yeah. If you can hear us, Kagiso, what you need to do is to log out and then in again. I'm sure you can hear us. Yeah, Kazi, you're not following instructions. Thank you, Buidu, for following instructions. Thank you, Shumi. Let's see about the rest if you follow instructions. Thank you, Teto. Nice, my people. Nice, Tando. Nice, Bui. Area, what you're not following instructions. Woo.
Oh, guys, we'll get it right at some point. Remember, I only want the 4 answers. I want all 4 answers at the same time. So like what Boitu, Shumi, like Yolanda was calling out names, that is how I want those answers. Makes it much easier not to miss an answer from the same person. Oops, sorry. And remember, guys, pop your questions on the chat if you have any.
I saw the message, teacher Sam. I'm responding to the learner.
Thank you. Alrighty, would we like to raise hands to give us some answers here? So if you want to give an answer, you can raise your hand. Well done on waiting until I said hands raised. Excuse me. Right, Senzo, give me A.
Ma'am, we're gonna say 3 times 0, which is gonna 3 times 0, which is gonna give us 0. Then you're gonna subtract 1, which is gonna give us -1.
Excellent, well done. Because my working out here, as Senzo explained it, is there at the bottom. Ooh. And so we get -1 as our output there. Very nicely done, well done. Woody, would you like to give us, what are we at, B?
So, ma'am, I said 2 times 3, which gave me 6 minus 1, which is 5.
Are you doing B or C? Sorry.
Oh, ma'am, sorry. I said 3 times 1, which is equals to 3 minus 1 minus 2, yeah, which is equals to 2.
Excellent, well done. So guys, 3 times 1 is 3, minus 1 is perfect 2. Well done. Oh, we got so many hands. This is wonderful. Well done, guys. Nkululeko, would you like to give us C?
So I said for C, we are going to say 3 times 1, or 3 times 2, ma'am. Then we said subtract 1, that gives us 5.
Excellent, well done. So guys, 3 times 2 is 6. 6 minus 1 is 5. So that's why our output here, exactly as Nkululeko said, is 5. Nice. Little Melo, would you like to give us D?
Ma'am, I say 3 times 3 equals to 9, minus 1 equals to 8.
Perfect. That was so honored and quick. 3 times 3 is 9. 9 minus 1 is 8. So those are all of our outputs according, and it's very important that we go according to our rule that we were given. All right. And guys, again, I know there's lots of hands. I will do my absolute best to get to everyone as we go through examples. Unfortunately, 76 of you, I can't ask all 76 of you for 4 answers. So very well done on putting your hand and putting yourself, making sure that you are willing to give an answer. We are going to do more examples, so please make sure you raise your hand later on when we do more. Right, so let's lower our hands now. What we've done is we found all of our outputs, and what that means is we can now go and use this information in order to go and draw a graph. All right, so what we need to remember, and I said this at the beginning of the lesson, but I'll say it again. What we need to remember is that this table represents coordinates at the end of the day. We've got an X and a Y, and we know coordinates are listed as X, Y pairs. So if we look at our very first column, we know that X was -2 and Y was -7. So I have got my first coordinate that I could potentially plot. If I look at my second column, I had an X coordinate of -1, a Y coordinate of -4. And so what I see is that this table gives me my coordinate that I can go and plot. So I've got 0, -1, 1, 2, 2, 2, 5, and 3, 8. And all of these coordinates, I can now go and plot on my Cartesian plane. I'm just going to make that a touch smaller so we can see our Cartesian plane. I will let you take screenshots just now, guys, so don't stress if you didn't get the table down. I will put it back for a screenshot just now. All right, so we have got these coordinates. We want to plot them. I'm just going to do a very quick refresher on how we plot coordinates. Remember, guys, that you've got two axes. You've got an x-axis, which is the horizontal one running left to right, and we have got our vertical axis, which is our y-axis running up and down. We also need to remember that where these two axes meet, we've got that origin point where it's 0 and 0 on both x and y. And then we just need to remember that on our Cartesian plane, we always want to have values so that we can actually go and plot the coordinates that we have. I'm just going to warn you now, I haven't made my axis big enough to plot all of the points. So we're just going to do our best. Generally, we try and give you a Cartesian plane that has enough space. Or if you have to draw your own Cartesian plane, just make sure you are making it big enough to plot all the points that you need to plot. All of the points that you need to plot. There's too many P's in that sentence. So just bear that in mind. So mine, I was missing a -7. I'm also missing an 8, but it doesn't matter. Right, 1, 2. Remember, as well, grade 8s, that on your y-axis, as you travel up, it's all positive. As you travel down, it's all negative. So that's why you can see all the way down my y-axis over here, my values are negative. Above, my y values are positive. Similarly, on the x-axis, everything to the right of the origin is positive. So here, everything to the left is negative. So I'll have -1, -2, and so on. So this is just a bit of a refresher on the Cartesian plane. This was all done in the very first lesson of this course. So again, if you're new, if you don't remember, I would go and watch those videos so that you know what's going on when we work with our Cartesian plane. All right, so now I can plot my points. Essentially, all I do is I plot a dot or draw a dot exactly where my points are. So if I start with the first one, that is at -2, -7. Now remember, it's x and then y. So I go to -2 on my x-axis, I go to -7 on my y-axis, and essentially if I imagine a dotted line, where they meet, I'm going to draw a point. So I have got a point that represents -2, -7 over there. It's a bit of an aggressive point, but it doesn't matter. So we read down from x, across from y, and where they meet, that is where we plot a point. Right, we can do the same thing with our second point. We've got -1 and we've got -4. Go down, go across, where they meet, we plot our point. And I'm going to do that with all of my coordinates. I'm just going to explain the third one because we did chat about this in our first lesson, but maybe you might have forgotten. If we're at 0 on the x-axis, it means we're right here at our origin. So we're on the y-axis. I then go down to where y is -1, and I plot my point on the y-axis. That point, this third point over here, is going to sit on my y-axis because x is 0. Then I keep plotting. I've got it 1, 2, 2, 5. This is where I don't have an 8 on my y-axis, but it doesn't really matter. Have I plotted this correctly? 1, 2, help if I plotted 2, 5 there. 2, 5. Now, hopefully what we're seeing is that if we kind of imagine a trend to these points, we are getting essentially a linear trend. And we'll discuss why that is in a second. But before we do that, let us actually complete our graph by drawing in a line. Now, what we need to remember, guys, is that any function that we draw will always have the points joined. Sometimes it's with a straight line, sometimes it's with a curve. It really just depends on the function. I have put in a couple curves just so that you can see what it would look like, but we always want to join our points to represent that relationship. So what we do is we now take our ruler, we draw a line joining those points. I maybe should have chosen a thicker line, but it doesn't matter. And I get my function. Now, very importantly, hopefully what you can, apparently that just moved all by itself. So that's an interesting turn of events. Hopefully what you can see is at the end of my line, I've got little arrows that I've drawn there. That is because this graph technically just keeps going. I can't draw all the way to infinity. That's not possible. And so what we do is we just pop little arrows on the end to show that this graph does keep going. It does extend to infinity. We just can't draw that. What we have here is a linear graph showing this relationship. Now let's chat for a second about why it is linear. Whoopsie daisies. So if we go back up to our table, or even you can use your coordinates, really doesn't matter. If we go to our table and we just look at the pattern that our y values or our output values create, right? So if we go here and we say, okay, what am I doing from -7 to -4? Well, I'm adding 3. -4 to -1, I'm adding 3. -1 to 2, I'm adding 3. Hopefully what we're seeing is that we have got a constant pattern that I'm applying. This is what we call our constant difference, but basically what it is we are adding exactly the same value to get from one y value to the next. We see this in the equation, that coefficient of x is also 3. That's showing that I'm adding 3 each time. And if we go to our graph and we try and see this relationship of adding 3, we can. If I go from point to point, so let's just start at this point over here, I'm going up 3 blocks, 1, 2, 3 blocks. From this point to this point, I've gone up another 3 blocks, 1, 2, 3. This point to this point, 1, 2, 3 blocks. And so that constant difference of 3, or that consistent adding of the same value every single time, is creating the straight line relationship for me. And this is why when we have a pattern or when we have a relationship where we're adding the same value every single time, we're going to get a straight line. Regardless of what the value is that you're adding or subtracting each time, you will have a straight line. So I'm gonna let you take a screenshot. If anyone has any questions, now is the time to raise your hand and ask me. I know it was a lot of information, a lot of it though we have done. So really only the drawing on of the graph and seeing the relationship is new. But again, questions, please ask. Watobe?
Ma'am, does it matter which side the positive or the negative is for the x?
Sorry, can you say that again? Does it matter which
side the positive or negative numbers are with the x?
Yes. So the negative numbers, so almost imagine it like a number line. The negatives are always on the left-hand side. The positives are always on the right-hand side. And it's the same for the y. It does matter. So for y, the positives will always be on top or above the x-axis. The negatives will always be below. So it always has to be like that, yes.
Nice, my people. And remember, for all of you maybe thinking she's lagging on my side, Teacher Sam is fine. Maybe my network is good enough. So it could be network issues, but don't worry, we're recording the lesson. So if you miss bits and pieces, don't worry, you'll have this lesson and you can repeat it at your own time, okay?
Exactly.
Trace.
Okay, guys, I'm hoping we've all got screenshots. You guys have done amazingly well. I'm going to take a little brain break. Then we're going to have a look at some more graphs. Hopefully we'll get to some fun ones. Otherwise, we'll get there on Wednesday. Right. Brain break. For those of you that are new, a brain break is quite literally what it says. We just take a little break from the specific maths that we're doing in order to give our minds a rest, give our minds a chance to hopefully process everything that we've done. And then we carry on with the maths. So today's brain break, remember what we always want from you is only this final answer here. So I want to know what 2 bicycles or Vespers or whatever they are, plus a race car times a ship is equal to. Bonolo, I'm glad you enjoy the joke. It's one of my favorites. I don't know why. I think it's hilarious.
Yeah, I also laughed quite a lot. And no people, I'm guessing that you just join now. So girl, don't panic if you just join now. You see, that's why I disabled the chat. Maybe I need to do so. They're entering in because those who are joining now, you end up panicking for no reason.
Okay, so guys, we are having a look at that brain break. I'm going to make it bigger just because it's very important that you see where you've got 2 ships, 2 bikes, 2 race cars instead of 1. You don't want to make a silly mistake. I was struggling to find the answer, but then I realized I was not looking at the fact that there were 2. So give it a try. Remember, we want final answers only in the chat, and when we see the correct answer, to explain to us how you did it. So don't just see a correct answer and then all of a sudden write it down, because when we pick on you, you're not going to know how to do it. So give it a try. It's basically like solving an equation.
Let's go, guys. We want a final answer. A final answer. Let's go. Let's go, my people. Y'all can do this. If I see the correct answer on the chat, I'll definitely let you know. Okay. I will let you know. So far, there isn't any correct answer. Y'all keep going. Let's see who's going to be the winner of our brain break. Remember, for those who are new, brain break is just for you to stretch, while we're busy trying this. Look, I don't see the correct answer yet. You need to do like the final answer. The rest of the steps, you can put it on on your book. I'm only interested on the last step where there's a question mark. So it's not 156, it's not 44. It is not that at all. It is not that. So let's get going. We can do it. Yes, Chantal is the winner of our brain break. Chantal, would you like to raise your... Oh, you guys are on it. You have no idea. You beat the other class, guys. You got it as fast as, I don't know, as lightning even. Chantal, do you want to unmute so you can explain to us? Are you finding it difficult? Let me just unmute you. You have to press on that button there that comes up.
Oh,
there we go. Well done.
good evening, ma'am.
Hi.
Ma'am, so the boats, one boat is equals to 7. So
2 boats
is 14.
Excellent.
So it's 14 plus 14 plus 14, which is equals to 42.
Good.
And the motorbikes or bikes are 5.
Good. And we know already that 1 boat is 7, because Chantal told us that. Okay.
And the race cars are 16.
Good.
16 plus
And what
16.
is 2 motorbikes now?
10.
Excellent. Well done. If 1 is 5, 2 is 10. Okay. So then the last step?
There are 2 motorbikes because equals to 10.
Good.
And there's 1 race car which is equals to 8.
Excellent.
And there's 1 boat which is equals to 7.
Good. Now, what do we do first? The times or the addition?
The times.
Good. What is 8 times 7?
56.
Excellent. Oh, you're much better at your times tables than I am. 56 plus 10 gives us the final answer, Chantal, of?
Is 66.
Excellent. Well done. 66. Well done, Chantal. Excellent. So, guys, that's how we do these brain breaks. Essentially, it is solving an equation. Okay, so when we get to our equation section, I'm really hoping that we're going to be super on top of it because we've done so many of these. Okay, so there is a reason that I give you these because it's going to eventually help you. And also just the thought process in terms of, okay, I'm adding 3 of the same thing. What does that mean? It's very important to understand that. Okay, Didn't how do I know the boats are 14? Okay, good question. So I'm adding 3 of exactly the same thing. I've got exactly the same picture that I'm adding 3 times. So if I have to add 3 of exactly the same value, I essentially need to ask myself, what number can I add 3 times to get 42? Now, let's not say a shortcut, but another way to do that is to say 42 divided by 3, and that gives me 14. So that's how I knew each of those boats were 14, because it was the same number added 3 times to get 14. Okay, well done, guys. So let's have a look at another example with drawing graphs. And like I say, most of the time, we're going to draw a straight line. That's generally what we work with in grade 8 and grade 9. But let's just see what we get here and why we get the graph that we get. So because you guys are on it, I'm just going to do one with you and then I'm going to let you go or let you try it. So if we have a look at our very first input of x equals -2, we've got our rule. We want to substitute that value in. So we would have y is equal to, and guys, just remember this negative x technically means -1 times x. So in the -1 there, that is fine. There's no problem with that. So we've got -1 times -2 plus 3. We know a negative times a negative is a +2 plus 3. So exactly as Tetel's put there, our output is 5. So what I want from you guys are the next, I want to say 5 outputs. So I'm going to again put some letters here for you. On the chat, I want you to do them all before you put answers down. So on the chat, I only want to see answers A, B, C, D, E. I want to see all 5 at the same time. So take a second. I don't expect them immediately, but take a second and tell me what those outputs are.
Let's see who's following the rules. I'm going to call out your name if you follow the rules. I'm going to give you like a high E5 if you follow the rules. Okay, so work on your book and then you can give us some answers, some interesting answers. I already love this class. You see, it's good to take your time, put it on your book, and then you can put it on your on the chat for us to see. And I can see our newbie, Keelan, is focusing. Who else? Who was new? Now Keelan's stuck in my head. Oh, Sange was also new. Sange is also focusing. Well done, Teto, on following the rules. Yes, guys. Yes, Sana.
Well
There
done,
we
guys.
go. Well done, my people. Remember, for all of you, I'm not saying that they got the answer correct. I'm saying they're following the rules correctly. There we go, Zaya. You're following exactly the format that we wanted you to give it to. Okay.
Well done.
And Amahle Shiba, sir, is also new. So Amahle, I'm waiting for your answers, doll. Mughal, let's go. It's your answers on the chat. There we go.
Grade 8, I will say this to you as well. The fact that you do actually listen to instructions means you're already 10 times better than most other grade 8s. I don't know what it is with some grade 8s. They just don't listen. So very, very well done.
We are so proud of you guys. So proud. There we go, Nosipo. We see you.
Nice, guys.
Shimmy. Nice. Katlisang. There we go. Shimi, I'm not quite sure what's going on with you, but
Oh, there was a mistake. I see.
yeah.
All right. Show me you were right the first time.
Sange. There we go. Our first new student is putting their answers down.
Well done.
Well done, Sange. We see you, Zintle. Also put the answers down. Yes. We see you, Lilu. Nice, guys.
Okay.
Yeah.
Let's get some hands for some answers here. So if you would like to offer an answer, please do raise your hand. Bonolo, would you like to give us A?
Yes, ma'am.
Hi.
Hi, ma'am. So firstly, we're gonna say -1 times -1, which is going to give us 1.
Good.
So we're gonna say 1 plus 3 is going to give us 4.
Excellent. So our output here, guys, is 4. Very nice, Bonolo. Well done. Well explained as well. Oh, right. Takulani, would you like to give us B?
-1 times -1 plus 2, which gives us 2.
Okay, you broke up a little bit there. I kind of got it. So -1 times 0 is 0. Yeah. So we've just done the -1. We want the 0, 1.
Which gave us 3.
Okay. There's a bit of a sound lag going on. Not too sure what's happening, but it sounds like you're on the right track and it sounds good. So I'm going to say well done. If we're at B, guys, -1 times 0 is 0. Plus 3 gives us an output of 3 over there. Okay. So we get 3. What's going on here? Sange, would you like to give us C?
Ma'am, for C, I said y equals -1 times 1 and then plus 3.
Okay.
And I got 4 as an answer.
Okay. Ow. So if we have a look at +1, if we've got -1 times +1, a negative times a positive is a negative. So we've got -1 plus 3, which will then give us +2. So 4 is if we had -1 as our input. Well done. Oh my gosh. I feel like I'm being attacked by bugs. Right, very nice. Panic. Tuhira, would you like to give us D?
Hi.
Hi.
So D is 2 multiplied by 1 plus 3 equals 2 plus 3 equals 5.
Okay, guys, I think we're forgetting this negative. Remember, it's a negative x. So -1 times +2 is -2 plus 3 gives us +1. So just remember it was the negative x in our rule. Okay, your maths is all good. So if we had -2 there, that would be perfect. And like I say, your maths is perfect. Just remember it is a -1. Well done. Little Melo, would you like to give us E?
Hello, ma'am. It's going to be -1. -1 times 3, that's going to be -3. -3 plus 3 is going to be 0.
Excellent. Well done. Okay, so guys, for that last one, our output is 0. And exactly as has been explained, -3 plus 3 is 0. So we actually end up with, let's not say no value, but we end up with a 0 value there. Right, so we can now plot all of these points on our Cartesian plane. Again, I'm just going to write our coordinates down so that we know exactly what it is that we're plotting. Otherwise, we might get a little confuzzled. So our coordinates are -2, +5, -1, +4, 0, 3, 1, 2, 2, 1, and 3, 0. So these are the points we want to plot on our Cartesian plane. Again, I obviously like to make work for myself and didn't put my numbers on. So I had the same problem last year and I complained about it every single lesson and then I didn't change it. Anyways, so again, just a reminder, where these axes meet is your 0 point. Anything to the right is positive. Anything above is positive. So that is where your positive values go. Anything then to the left of that 0 point is negative. So that's my negative x values. And then anything below that origin or that 0 point is negative. So when I now start to go below my 0 point, I've got -1, -2, and so on. Oops. That wasn't great. Let's try that again. Alrighty, so now we can plot our coordinates. I think I'm gonna do it in a different color here because that's a very aggressive situation going on. Right, so the first one, -2, 5. I go to -2 on the x, I go to 5 on the y, essentially where they meet up. Oh, please don't fight with me. Essentially where they meet up, that's where I'm gonna plot my point. Don't know if my laptop's just decided it's tired. You know, doesn't really get that choice, but anyways. Right, so there's my first point, done. Second point, I'm going to plot -1, 4. That's also not my point. I'm going crazy. Clearly my laptop's not the only one that's tied. Let's try that again. -2 on the x, +5 on the y. So my point is actually up here, losing it. Right, there we go. Next one, -1, 4. Where they meet, plot my point. Now, guys, this third one is again quite similar to the first example that we did. We've got 0, 3. So 0 is here on the y-axis. So I'm on the y-axis, and now I go up to +3, and I plot my point on that y-axis. The next one, a little bit easier, 1, 2, then 2, 1. Now, this last one, again, we just need to be careful. It's at 3, 0. So 3 is my x, 0 is my y. So I go along to 3 on my x-axis, but y stays at 0. I stay on this x-axis. So I plot my point on the x-axis at 3. Now I can see quite nicely here that this is once again going to be a straight line, and we draw our straight line joining our points. Now, I'm doing this for a reason, so don't worry that I'm exaggerating this line just a wee bit. So when we draw a graph, okay, it all just went badly. Okay, when we draw a graph, what we want to do is we always want to extend that graph all the way to the end of my Cartesian plane. So I've done, losing my mind. So we've done points up to 3, but I've extended my line past that. And again, it's to show that this relationship continues to infinity. All right, so drawn my straight line, plotted my points, there's my graph. Excuse me. What I want you to see, and let's just, I don't know how small I can make this. What I want you to see is that the graph we drew in example A and the graph we've just drawn in example B are different from each other. Yes, they're both straight lines, but they are different. What we see in the first example is that my graph was increasing from left to right. But what I now see in example B is that my graph is decreasing from left to right. And there's a reason for that. So if we go back to graph A, we spoke about the fact that the constant difference we had was we were adding 3 each time. If we have a look now at this example B and we go and look at what our pattern is, we can see that our pattern is that we're subtracting 1 each time. Now, because that constant difference is negative, so I'm just going to write it here, our constant difference, but I have to spell constant there for a second, is a -1. That negative means that my graph is decreasing from left to right. I'm still subtracting the same number. I can see that I've subtracted 1 block, I've subtracted 1 block, and I've subtracted 1 each time to get 1 point to the next. But because I'm subtracting now, my line is decreasing. And that's important to start seeing. Excuse me. It's important to start seeing these sort of relationships, that when we're adding a value, when we're adding a value, our graph is going to go up from left to right. When we are subtracting a value, we are going to have a graph that decreases from left to right. All right, so I'm going to stop there for you guys to take screenshots. I see there's a couple questions that I had. Rotondua, we know that X and Y are the specific values they are because from, that was terrible English. Let's try that again. Because in our table, I told you that the input was X, and then I told you that the output is Y. So everything in the first row are X values. Everything in the second row are Y values. I also then know on my Cartesian plane what is X, because X is always the horizontal axis. So it's always the one horizontal, and Y is always the vertical axis. And so I always plot it according to that.
Sorry, before we continue, guys, Teacher Sam is not lagging, okay? So it could be your network, and I don't know what else to explain to you. But I think that you actually do get her, and you get what she's talking about. She hasn't lagged into for us to panic that we can't understand. Okay. So
and guys, remember, yeah, if you're struggling, just remember it's recorded, so you can go and watch it. We get that, like with 11.5 hours of load shedding a day, sometimes it's a struggle. It's okay. Okay, guys, so take those screenshots. If anyone has any questions, now is the time to raise your hand and you can ask me. Hopefully this is making sense. Like I said, I love functions. It's one of my favorite sections. Whether it's trig functions or linear functions, it's such a cool section. And often people ask, when will I ever use this in real life? Something like this. Profits for a business. You want your profits to increase. We don't want a profit line to look like that. We want a profit line to go up. If you think about, if you ever want to be a scientist and you think about like population growth, we can plot that as a graph. If you think about, I'm trying to think of other examples. There was a cool one I Googled the other day. If you think about like, and sure, my science is now a bit rusty. If you think about like signals bouncing off of satellites and then coming back to Earth so that we can get like internet and TV and all of that stuff, that you can plot as a graph. So all of these really cool relationships that we do actually have in real life, we can have as a graph. Got very excited really about graphs for a second.
Yeah, but it's really cool, and it's a cool explanation. It makes us want to study more. I'm gonna launch the poll. Is that fine?
Absolutely. I see Tekofatso has a question. So while the poll's up, I'm just going to answer. Tekofatso, tell me.
Can you hear me, ma'am?
Yes.
So I wanted to ask, in our exams, are they going to show the y and the x's like that?
What do you mean show it like that, like on the Cartesian plane?
Are they going to indicate where the x is and the y?
So they should. So if we give you a Cartesian plane, we will generally put the y and the x there, yeah, because it should be there. That's a standard label that should be on your Cartesian plane.
Okay, thank you.
Sure. All right, guys, so this is definitely one of the sections in maths that like is applicable to real life. You will see graphs a lot in real life.
Yep. And Nosipo, you should have a pop-up on your screen. If you're using a phone, maybe you just need to swipe either left or right to see the poll.
It just goes-
Yeah, when you actually participate, time flies very, very fast. If you're listening to the instruction, you're participating, you are actually enjoying. And then it flies.
Yeah. And it's also like when you start to enjoy things, and even if like you're not enjoying this yet, or it's still starting to make sense, that's cool. But like you guys can do it. And maths is fun. I know not everyone agrees with that. I completely understand. But
It's really fun though.
I get so excited about maths. My kids laugh at me all the time. But like, yeah, it's fun.
Yeah.
Anyways, I'll calm myself
amazing.
down. Okay, guys, come. We're at 91% for this poll. Let's do this. Dindley, I'm very glad to hear that. Bukani, I get that maths is sometimes hard. I do understand that. I struggled through maths sometimes at school as well. You just got to keep working. Okay, you can do it. Senzo, will we ever do this with a constant ratio? I assume you mean graphs, and yeah, we could plot it as a why are my words gone? As a graph. Yes. Jeez Louise, we got there in the end. So really anything, as long as you've got an X and a Y, you can plot it and get a graph.